All right, if you're sticking with me, you want to know where the heck does this thing come from? And it actually comes from the idea of acceleration, average acceleration, and average velocity. So one thing I need to tell you about average velocity, this is how we told you to figure out an average. There is another way to get an average velocity, and that would simply be to say, well, take your final velocity, add it to your initial velocity, and then divide by 2, and that would give you an average. So I have another way I can say this. If both of these are average velocities, I can then say the following, that the displacement divided by time, which is an average velocity, has to equal an average velocity, which is my final velocity plus my initial velocity divided by 2. So with that set up here, I can start to go through this, because the two equations that I'm going to focus on here are this one here and this one here, but we're going to do it in two different ways for each one of the equations. So if I'm looking at these two equations and I'm looking at this equation, what is missing from this equation that we find in both of these? And what we find is final velocity shows up in both of these, but final velocity is not there. So what I want to do here is rewrite this equation so I have final velocity all by itself. So in order to do that, I'm going to solve this for final velocity, which means I'm going to multiply t to both sides. So I'm going to get time times average acceleration equals final velocity minus initial velocity. And then to get final velocity all by itself, I'm going to add the initial velocity to both sides. So I end up with final velocity equals the initial velocity plus AT. I just wrote those backwards that way. So that's one way of describing a final velocity. So that's going to become important in a moment. I want to do the same thing with this one. Oops. I'm going to solve this one for final velocity. That should be a 2 there, my mistake. So the first thing I'm going to do is multiply both sides by 2. So I get 2 times the displacement divided by the time equals final velocity plus the initial velocity. And now to get final velocity all by itself, I'm going to subtract VI from both sides. And I get final velocity equals, let's see, 2 times the displacement divided by time minus the initial velocity. So now I took both of these equations and rewrote them so final velocity is by itself. And now, since this is final velocity and this is final velocity, I can take this thing here and this thing here, set them equal to each other, and we'll see what we'll get. So I'm going to start with this one here. I'm going to say 2 times the displacement divided by time minus VI equals, that's final velocity. Final velocity equals this, the initial velocity plus acceleration times the time. Well, now we'll just clean it up a little bit. Let's get the initial velocities on the same side. So I'm going to add VI to both sides. So I get 2 times the displacement over time equals, if I add VI to both sides, I get 2 VI plus acceleration times time. We're getting there. Well, I want to get time out of the bottom here, so I'm going to multiply both sides by time. So this becomes 2 delta x equals 2 VI times t now, because I'm multiplying that by time. I'm multiplying this one by time, plus AT squared. And now to get delta x all by itself, I'm going to divide everything here by 2. So I get delta x, or displacement, equals, well, 2 divided by 2 drops out, VIT, plus AT squared divided by 2. And if I want to move the 2 out in front, I get the equation we were looking for. The displacement equals initial velocity times time plus 1/2. Instead of putting the 2 underneath everything, I just pull it out in front. 1/2 times acceleration times time squared, which is what we were trying to get at the beginning. Okay? So that's how it's done. There's no magic involved. It's just taking things that we know and solving them for one thing or another. So the second one we wanted to look at was, where did this guy come from? Where does this one come from? Okay, well, doing the same thing. I did the same thing here before. You can look back at the other one. There's another way of saying average. So I just took these two and said they're equal to each other, and I set them here. Move it down here a little bit, sorry, so you can see everything. So now, what is missing from this expression? Well, the obvious answer is time doesn't show up here. So I want to take this expression here and solve it for time. So this is pretty easy. Time, I'll move over to this side, but then I have to divide by acceleration. So I get time equals final velocity minus initial velocity divided by acceleration. So that's one expression that I'm going to need. And then this one here, I need to rewrite this one, so times by itself. I'm going to do this kind of quick. I'm going to multiply 2 to this side, so I'm going to get 2 delta x, 2 times the displacement. I'm going to multiply time to this side, so that's going to equal VF plus VI times time, because I want it out of the denominator. And now I'm just going to divide both sides by what's in the parentheses here. So I'm going to end up with time all by itself here. And on this side, I'd have 2 times delta x divided by VF minus plus VI. Okay? So that's taking this expression here, solving for time, it would look like that. Taking this expression here for acceleration, solving for time, we get that, which means this guy here equals this guy here. Those are the same, so let's set them equal to each other. So I'm going to say VF minus VI over acceleration equals this one here, 2 times the displacement divided by VF plus VI. Okay? So now I want to get everything out of the denominators. So I'm going to go ahead and do that. I'm going to multiply a to both sides. So this side is going to end up being 2 times acceleration times displacement. It's starting to look like our answer here, isn't it? And I'm going to multiply over here, VF minus VI. That's what's already there, but I'm going to multiply it by this quantity, VF plus VI. Okay? So now we're going to factor this out and see what we get. And so here, you might remember this from your math classes. VF times VF, well, that's VF squared. Then I have to distribute VF times VI, so that's positive VF VI. Then I have to do the inside. VI, negative VI times VF is negative VF VI, so those cancel out. Then I do initial velocity, which is negative, times the positive initial velocity, so it's going to be minus VI squared, and that equals 2a delta x, which is our displacement. And the final step to get to where we're looking here, I'm just going to add VI squared to both sides, and I get VF squared equals VI squared plus 2 acceleration times the displacement, which is what we were looking for at the beginning. Okay, so you don't have to go through this ever, but just so you know that these expressions didn't just come out of nowhere, they actually have some meaning and they come from something. So there you go.